Hello and welcome back to the puzzle solution lessons under the analytical section from GRE Big Book. In this lesson, we will be going over the 27th test. So let's get started. So the questions we have here is, at an art show, exactly 5 sculptures are to be displayed in a room with exactly 5 stands, arranged along single wall and numbered consecutively from 1 through 5. The sculptures are to be selected from a total of 8 sculptures, M, N, P, Q, R, S, T, and U, and displayed one sculpture on each stand according to the following conditions. The conditions here are either M or U or both must be selected. If M is selected, M has to be on stand 1. Either R or S must be on stand 3. If T is selected, P must also be selected, and T and P must then be on stands that are immediately adjacent to one another. Okay. So let's go to the questions. The first question is, which of the following is an acceptable selection of sculptures to be displayed on stands 1 through 5? Okay, so we have our options. The first option is MRTPQ. So let's go over the conditions first. It says either M or U or both must be selected. So, okay, M is selected here. So this one's checked. If M is selected, M must be on stand 1. Okay, it is on stand 1, so it's checked. Either R or S must be on stand 3. Oh, we see here that T is on stand 3. R or S are not on stand 3. So this one is not correct. So cross. Next one, B. NTSUQ. Okay, so the first one it checks out because U is here at number 4. We don't need this one because M is not selected. Either R or S must be on stand 3, which is yes, S is on stand 3. Um, if T is selected, P must also be selected. Okay, but we see that T is selected, but there is no sign of P. So this one is also not correct. Okay, let's go to number C. Um, First one checks out. We have U. The second one we don't need it because M is not selected. Either R or S must be on stand 3, which is yes, S is on stand 3. If T is selected, P must also be selected, and T and P must then be on stands that are immediately adjacent to each other, which is yes. So this one, this one checks out all the conditions, but just in case, we'll hold it and move on to the next one. D. Uh, Here we can see it violates the second condition. M is selected, but it is not on number 1. So this one cross. And number E, UNQPT. Now, with this one, we see this one. R or S must be on stand 3. We see Q is on stand 3. R or S is not on stand 3. So this one is crossed. So our correct answer here is C. Now, there could be some confusions here. A lot of people will say, okay, but uh, isn't there a world where R or S are not selected? Well, we can't assume that because it says must. Whenever we see the word must, we need to make sure that certain sculpture is included within the pile. So through that condition, option E is also out. So our correct answer is C. So first one checks out. Nice. Uh, mm. So on to question number 2. We have, if S is on stand 1, which of the following must be true? Now, this is quite an easy one, but still I'll go through the process. Let's say these are the stands. 1, 2, 3, 4, 5. Let's just number them. 2, 3. Excuse my handwriting, by the way. I'm drawing with my mouse. So 1, 2, 3, 4, 5. It says S has to be on number 1. Okay, so we're putting S at number 1. You know what? Let me just use another. Yeah, S is on number 1. Now, if we go through this condition, it says either R or S must be on stand 3. So here we see that S is already in stand 1. So we're only left with one other option, which is R must be on stand 3. Now, let's go over the options. And we see at number B, it is R is on stand 3, which is our correct answer. Now, you can go over the whole thing with the trial and error process with P at somewhere other than 4. Let's just say you want to prove that P is not on stand for so that you can eliminate this option. You can easily try it with P at, I don't know, like at 5 or 2 or 1 or something like that. But it's quite a time consuming one. And it's quite easy to just go through the conditions and decipher what the correct answer is. So for this one, the correct answer is B. R is on stand 3. Nice. On to the next one. Uh, okay, moving on to question number 3. If T is on stand 5, which of the following pairs of sculptures can be on stands that are immediately adjacent to each other? Okay, so let's see. So firstly, we have to put T at stand 5, which is here. You know what? Let me just use another color. Okay. T at stand 5. Now, based on the last condition, we know that if T is selected, P must also be selected. And T and P must then be on stands that are immediately adjacent to each other, which is, by the condition, we already know P has to be here. Let's be real. Okay, now, from the from this condition, we know that either R or S must be on number 3. So, we can already cross out this one and this one because uh, adjacent to P, we can only have R or S. So that one's crossed out. And again, with this one, R and T cannot be adjacent to each other because P is in the middle and R is at the end of the line. So you can cross out this one as well. Now you're left with two, Q and N, U and R. Okay, so uh, so what we see here is that Q and N, right? Uh, it says can be on stands that are immediately adjacent to each other. So you can easily put U here. You can easily do it because, you have to either select M or U. So you need M or U. So this one, at number 1, you can put anything. It really won't make a difference. You can put M, you can put Q, you can put N, whatever. It doesn't make a difference. But you need U. You can easily put U at number 2 or number 1. And it says can be. So you can be at number 2. So this one is possible. But B is not possible. Now, why is that? Because we know 3 of the 5 are already selected. T has to be at number 5, P has to be at number 4, R or S has to be at number 3. And now we're left with 2 other options. Now, the 2 other options, we know that one of those 2 have to be either an M or a U. Now, this is where the trick comes into play because you cannot just say Q and N have to be next to each other because one of those 2 alphabets have to be U or M. So by that logic, you cannot put Q and N adjacent to each other. So the correct answer is U and R. Now, on to question number 4. Now, the question says, if U is on stand 4, any of the following can be on stand 5 except. Now, this is a tricky one. So I'll go over it here. So we know U has to be here. And now, the question is, any of the following can be on stand 5 except. Now here, you need to kind of understand a certain scenario. Let's go over this one, this last condition. It says, if T is selected, P must also be selected, and they have to be next to each other. Okay, understandable, pretty common. Now, from first impression, it would seem that none of T or P can be at number 5 because they need to be adjacent to each other. So by that logic, the answer should be both B and E. You know what? I'll just cross off the other ones just for clarity because it's understandable. I mean, I'll still go over it. I mean, you might think that R has to be at number 3, which is not necessary. You can have S at number 3 and um, are at number 5. It's quite possible. And there's no certain constrictions for N and Q, so you can definitely put them at number 5. But for P and T, you might assume that none of these 2 can be at number 5 because you need them to be next to each other. But here's the trick. It says if T is selected, P must also be selected. Now, it's not the vice versa. It says when T is selected, you need P. But when P is selected, you necessarily don't need a T. And that's why the latter part of the condition doesn't apply when P is the one being selected. So in these sort of scenarios, we can easily place P. Let's just say P has been selected, right? We can put P anywhere. We can put P at number 5. There's no issue because in this case, you don't necessarily need to select T alongside P because this condition doesn't work both ways. It's a one-way condition. It says T is selected, P must also be selected, not the vice versa. And the latter half of the condition is only applicable when the first half is in progress. So when the first half is not in progress, you don't even have to consider the second half of the constriction. So P can definitely be at number 5. So we can cross out P, and the only solution we're left with is T. Because if you select T, then P must also be selected. And P and T must then be on stands that are immediately next to each other. So you cannot put T here. You cannot put T here because then you don't have a space in which you can put sculpture P. So yeah, the answer is T. I think it's comprehensible for now. I think I tried my best to um, make you guys understand why this condition is the key here, and there's quite a bit of a trickery. So nice. Moving on to the next one. Okay, moving on to question number 5. If T is on stand 2, which of the following sculptures must be selected? Okay, so let's just say uh, T is here, and we know in number 3 you need an R or an S based on this condition here, this one, if you can see my cursor, this one. And then the last condition, if T is selected, P must also be selected and they have to be next to each other. So the only space left for T to go is at number 1. Sorry, P has to be at number 1 so that they're next to each other. Now we're left with two spaces, 4 and 5. Now we know from condition 1, either M or U or both must be selected. So we need either an M or an U or both in these two spaces. But there's a catch. You cannot have M because if M is selected, it must go on stand 1. But we already have P at stand 1. So by that logic, you cannot use M. So you can use U either, sorry, you can use U either at number 4 or at number 5. So that's basically the catch. So you have to be the one that needs to be selected. So the answer is U. Okay, moving on to question number 6. It says, if P is not selected and R is on stand 1, which of the following lists in alphabetical order those sculptures that must also be selected? Now, we have quite a lot of info here. The first one is P is not selected. Okay, and by that logic, we know that T cannot be selected either. Because if T was selected, P must also be included. But by this logic, T must not be selected. And then R is on stand 1. We know that. R is on stand 1. And from the condition here, R or S must be on stand 3. We know S has to be at number 3 because R is at number 1. Okay. Am I right? Uh, Now very large. Okay. And we know that U has to be selected because M cannot be. Because if M was selected, M must have gone at stand number 1. So U is the rightful choice. U has to be either at 2, 4, or 5, or whatever. Up to you. And now, this is where I love going to the options to test out the waters. So let's just see. It says M, Q, T, and U. We have already established that T cannot be one of the sculptures that are selected because P is not selected, so T cannot be selected either. So this one is a crossed out. Again, this one also has T, so crossed out. Number D also has a T, cross out. Number E also have a D, sorry, T. cross out. So C is the only one that does not have T. But then again, we'll just make sure that we're on the right track. So we already know that R is at stand 1 and S has to be at stand 3. We need to include a U. So for this one, the alphabetical order, we know N comes first out of these four, so that's fine. Then Q comes next, that's fine. S comes afterwards, and then U. So the alphabetical order is correct, so that's fine. And it also shows that we have S and U, the two that we have established that must have to be included. Now, for the remaining four, as I've said, T cannot be included, M cannot be included. So the logical ones are N and Q. So N can go here, Q can go here, or vice versa, or whatever. You get my point. The basic trick was that T cannot be included, so the options that included T needed to be omitted. So A, B, D, and E are gone. So C is the only rightful answer. On to the next one. Question number 7, and it says, if Q is displayed on a stand immediately adjacent to a stand on which R is displayed, and immediately adjacent to a stand on which S is displayed, which of the following must be true? So here, uh, we need to visualize something. We know that one of R or S has to be at number 3, and Um, the question says, if Q is displayed on a stand immediately adjacent to a stand on which R is displayed and immediately adjacent to a stand on which S is displayed. So by that, we can understand is that Q is in the middle of R and S. And the only way for that to be possible if we put R and S at number 1 and number 3, or if we put R and S at number 3 and number 5. Now, a lot of questions might be that why is R and S not at 2 and 4? That's also a possibility because then again we can put Q at number 3, which is the middle of the two. Wrong. Because from the third condition, we know that R or S must be at number 3. So we need one of these two at number 3 for the condition to be met. So now the premise is that you have one of these two at 3, and you have one of these two at number 1 or number 5. So Q can either be at number 2 or number 4. Now, let's go over the options. Now, we can see in the second option, it says P is on either stand 2, sorry, Q is on either stand 2 or stand 4, which is the right answer. We have only established this right here. And now, moving on to question number 11 to 15. Um, the premise is, from time to time, the managing director of a company appoints planning committees, each consisting of exactly 3 members. Eligible for appointment are 3 executives from finance, F, G, and H, and 3 executives from operations, K, L, and M. Any given committee is subject to the following restrictions on appointments. At least 1 member must be from finance, and at least 1 member must be from operations. If F is appointed, G cannot be appointed. Neither H nor L can be appointed unless the other is appointed also. If K is appointed, M must also be appointed. Okay. Moving on to the question. 11. Which of the following is an acceptable committee? Okay. So let's see. F, H, and M. Okay. Let's go over the conditions. The first one is at least 1 member must be from finance and at least 1 member must be from operations. I mean, it checks out the first one because F from finance and M from operations, so that one is ticked. If F is appointed, G cannot be appointed. Okay, yeah, we have F but no G, so okay. Neither H nor L can be appointed unless the other is appointed also. And it violates the third condition. we have H here, but no L. So this one is wrong. So we can cut it off. Yeah. With B, uh, the first one is yeah, we have one from finance and one from operations. Uh, then the next one is if F is appointed, you can yeah, we only have G and no H, no F. And then the next one is neither H nor L can be appointed unless the other is appointed also. So yeah, we don't have an H here, we have an L, so this one is crossed out as well. We need to have both H and L together, if they're selected, that is. Moving on, H, K, and L. I mean, it satisfies the first condition with finance and operations having at least one member. If F is appointed, G cannot be appointed. I mean, we don't have either of those two, so it's useless. Neither H nor L can be appointed unless the other is also appointed. So we have H and we have L. So for now, it's doing well. It ticked out this one as well. If K is appointed, M must also be appointed. Now we have K but no M. So this one is crossed out as well. Moving on to D, H, L, and M. So now uh, for H and L, I mean, yeah, this one ticked out. Neither H nor L can be appointed unless the other is also appointed. So ticked out. Fine, one from at least one from finance and at least one from operations. We have H from finance and we have M from operations. So that one is ticked up as well. If F is appointed, G cannot be appointed. So we don't have either F or G. So that one is useless. And then the last one, if K is appointed, M must also be appointed. Now, point to be noted is that it doesn't work vice versa. That is, if K is appointed, M must also be appointed. That one is correct, but it doesn't necessarily mean that if M is appointed, K must also be appointed. So here we can have M on its own without um, having um, K to accompany it. So this one is right. It ticks out all the criteria so far. um, H and L together, one from finance, one from operations, and then yeah, M is there, and then the last one, KLM. And I mean, we can already tell that neither H nor L can be appointed unless the other is also appointed. We have L here, but no H. So for not having an H, this one is cut off. So the only rightful answer is D. Now, I'll go over it again just to make sure that everyone understands it properly. Uh, this last one, this one, uh, this one means if K is appointed, M must also be appointed. But it doesn't really mean the reverse. That is, if M is appointed, K doesn't necessarily have to be appointed. It's not a must. It could be, but it's not a must. So that's why we can have M on its own, but we cannot have K on its own. If we have K, we need an M to accompany it, but if we have an M, we don't necessarily need a K to accompany it. So by that logic, number D is correct. Moving on to the next one. Uh, okay. Moving on to question number 12. If appointees from finance are in the majority on a committee, that committee must include which one? Okay. So let's just say we have a three-member committee because we already know it's a three executives. So we need to have people from finance to be in the majority. Now, from this condition here, we know that F and G cannot be in the same group. So we need at least one of these two. So we will have two different scenarios here. This is scenario number one. In scenario number one, let's consider F and H because we need at least two out of these three to be in the committee to have the majority in favor of finance. So let's go with F and H for now. F and H, F, H, and if we have H, we also need to have L. So there you go, F, H, and L. This is the first criteria. I mean, first case. Sorry. And now we're moving on to the second case. Now, in the second case, we will consider G instead of F. Uh, let's consider G, and let's consider H, and then we will have L. So these are the two possible scenarios in favor of finance having the majority within the committee. So what we see here is that the first two are interchanging, not interchanging, just changing. Um, Once you have F, and the second time you have G, but the other two letters, I mean, executive, are staying the same. So now let's go to the options. So the first one is F. I mean, it's not a must. We have already established that in one case we'll have F, in one case we can have G. So this one is crossed out. Same case for G, crossed out. I mean, K, no, we can't have K here. We can have L. Yep, L is present in both cases. So I'll just keep it for now. And M, yeah, we cannot have M. So the only option that matches the condition and that must be present within that committee is L and H. And in the options we have L. So L is the rightful answer. Nice. Okay, moving on to question number 13. If appointees from operations are in the majority on a committee, that committee must include. Okay, let's go with 3. Okay. Now, we need at least 2 out of KLM to be in the committee. So, for that, I mean, we already know uh, if we appoint K, we have to appoint M. So, let's just start with that. Let's just say we have appointed K, and then we have to appoint M as well for that reason. And then we can appoint either F or G. Now, why not H? Because we cannot have H for this case. Let's just say it's case 1. We cannot have H for case 1 because if we have H, we also need L, and that's not possible. That's not possible. So we can have H here. Sorry, we cannot have H here. We need to have either F or G. We can have either F or G. Okay, moving on to case 2. Let's go for another. For case 2, uh, let's say we have I don't know, like we have taken L. We have taken L as the first one, and uh, M as the second one. Now, one point to be noted is that if K is appointed, M must also be appointed, but not the vice versa. I think I've already established that. You can have M on its own, but you cannot have K on its own. So it's completely logical to have M alongside L. So we still have the majority in favor of operations with 2 out of the 3, L and M. And because we selected L, we need to have H because we need to fulfill this condition as well. So LMH. So these are the two scenarios that we're looking at right now. So now let's go to the option and let's read the question again. If appointees from operations are in the majority of a committee, that committee must include. Now we need something that is a must. And from these ones, we already know M is the must. So answer should be E. On to the next one. Okay. Um, on to question number 14. The question is, if F is appointed to the same committee as M, which of the following will be true to that committee? Okay, so I mean, let's just go over that. Um, we have F and we have M. So something that we need to establish here is that we cannot have G because we have F, we cannot have G, and we also cannot have what else can we not have here? Let's see. We also cannot have L or H because if we have either of these two, we need the other one as well. So L or H cannot be present here. We cannot have L or H. So let me just say which ones are not possible. So L, H, and G are not possible. These are not possible. Uh, Let me just use a different color. Yeah. So these ones are not possible. Uh, and so we are left with K. Uh, and yeah, that's pretty much it. So this has to be K. Now let's go over the options. If F is appointed to the same committee, then which of the following will be true to that committee? Okay. Appointees from finance are in the majority. No, that's not true. So I'll just cut it. We have from operations as the majority. Appointees from the operations are in the majority. Yes, that is true, but I'll still hold it for now. G is a committee member. No, G is not a committee member. L is a committee member. No, L is not a committee member. K is not a committee member. No, that is also false because K is a committee member. So this one is out as well. So um, B is the only rightful answer because it says appointees from operations are in the majority, and this is true because we have M and K. So the right answer is B. On to the next one. Okay. On to question number 15. Uh, if the restrictions on the appointments apply also to a four-member committee appointed from the same group of executives, which of the following will be true? Okay. So this time we have four people in the committee. So, I mean, I think this one is just a trial and error one. So, uh, let's just go with it. Yeah. Uh, let's start from option number E. Now, in these sort of stuff, you want to prove that, you know what? I'll just demonstrate. I'll just demonstrate. Let's start with option number E. Let's start with option number E. Let's see. One, two, three, four. Um, it says if M is appointed, K must also be appointed. Okay, let's see. Let's see if it's true or not. We have appointed M. And now this is what I'm trying to do. I'm trying to prove the opposite, that if M is appointed, then it is not a must that K also has to be appointed. So I'll just try to prove that we will appoint M, but we won't appoint K. So let's just say we have appointed M, and now let's just say we'll appoint F. If we will appoint F, and then let's just say we'll appoint H. And if we appoint H, we will also appoint L. Well, this still maintains all the criteria. We at least have one member from operations and at least one member from the finance. We have H and L together. So this is a possibility. So option E, if M is appointed, K must also be appointed. So this is not true. So I can cross it out. On to the next one. Let's see. In case of option number D, um, hmm, let's see. If L is appointed, G must also be appointed. Let's say L is here. I mean, I'm going to go down the same route as well. I'll just try to prove that if L is appointed, G is not necessarily a must to be appointed. So let's just say I picked L, then I have to pick H as well. And similarly, I mean, I'm just going to go down this route. I'm just going to take uh let's say I'll take K and then I'll take M. So it still fulfills all the criteria. I mean, we have L and H together, we have K and M together, then we have one from finance, we have at least one from operations. Yeah, I mean, it fulfills the criteria. So uh, D is not a must again, so cross out. Um, let's go for C. Let's see what C has. If H is appointed, F must also be appointed. Okay, H is appointed. F must also be, well, not really, because look, we can already establish it from the second one that we have appointed H here, but there is no F. So we can automatically say that if H is appointed, F is not a must to be appointed. So cross. Uh, if G is appointed, K must also be appointed. Okay. Let's see. Uh, option number B. One, two, three, four. If F is appointed, if G is appointed, K must also be appointed, right? Okay, so let's just say I have G here, and let's just say I have taken H, and I have taken, if I have taken H, I have taken L, and then I mean, I can just take M. So yeah, uh, this also satisfies it. So it's not a must for K to be selected alongside G. So it's a cross as well. So by the process of elimination, A has to be our correct answer, but still, I will try it out for myself. Um, okay. Um, for A, we have if F is appointed, M must also be appointed. Okay. So let's say I've appointed F, and let's just say if I have appointed F, I've appointed H as well because I can appoint G. So if I have appointed H, I have to appoint L, and then I'm left with one empty space. So in this empty space, I mean, I can only have M because if I have K, I would need an extra additional space to accommodate M as well because from this condition, we know that if K is appointed, M must also be appointed. I mean, you can see another version of it. Appointed F, and then I've appointed K. If I've appointed K, I've appointed M, and if I have appointed M, then I cannot appoint anything else here because if I appoint H, then I also have to appoint L. So there's only one space left, but I need to fit two different executives here. So this last one is not possible. So this is the only viable case we have. So this is the right answer. If F is appointed, M must also be appointed. On to the next one. Moving on to question number 16 to 18. The premise given here is that a psychologist has designed an experiment that involves running five mice, F, G, J, K, and M, through a maze that is connected to five compartments, 1, 2, 3, 4, and 5. The psychologist places each mouse in one of the five compartments. When a bell is rung, each mouse leaves its compartment, runs through the maze, and enters or re-enters one of the five compartments. At no point is there more than one mouse in any compartment. When the bell is rung, any mouse placed in 4 always goes to 2, and any mouse placed in 2 always goes to 4. When the bell is rung, any mouse placed in 5 always goes to 3, and any mouse placed in 3 always goes to 5. The psychologist has designed the experiment such that after the mice have run through the maze, the following outcomes always obtained. M is neither in 3 nor in 4. If J is in 1, K is in 2. If M is in 2, K is in 5. Okay, a lot of information given here. What we have to keep in mind is that there are five mice and there are five compartments, and there are some conditions given before they start running, and then there are some conditions given after they have completed the run. So let's just put it into perspective. Let's just say before. Uh, excuse my handwriting, by the way. Before. Uh, uh, let me just use another color. One, two, three, four, five. We have five, and then we have after. And after. After. Um, one, two, three, four, five. Uh, uh, let's just number them. One, two, three, four, five. One, two, three, four, five. These are the compartments. Uh, this one is for before and this one is for after. We still haven't gone into the question portion, so I'm not really filling in the mices here. But apart from that, this is the scenario that we're working with at the moment. So let's just go into the questions. The question is, which of the following is a possible distribution of the mice after they have run through the maze? So we need to be working with these constrictions here because these are the after conditions. The run has been completed and now the mice have entered certain compartments and now we will work with it. So let's just see. Uh, with option A, we have J, K, M, F, and G. So let's just go through the conditions. M is neither in 3 nor in 4. I mean, yeah, we see that It violates the first one. So M cannot be at number three. So cross. It cannot be A. Number B, G M K J F. Now with this one, the last one, if M is in 2, K is in 5, we see M is in 2, but K is not at number 5 or compartment 5. So this one is crossed out as well. And number C, we see F, J, G, M, K. Again, uh, with with this one, the M is neither in number 3 nor in number 4. We see that M is in fact at number 4 in option C, so it also violates the given condition, so it cannot be the answer. Number D, we see J, M, F, K, G. Once again, we have M at number 2, but K is not at number 5. So this one is not correct either. So by the process of elimination, we're only left with E. So E will be the correct answer. But then again, let's just go over it. Uh, M is neither in number 3 nor in number 4. Okay, M is at number 1, so that checks out. Um, if J is in number 1, K is in number 2, J is not at number 1, so we don't really have to worry about this one. If M is in number 2, K is in number 5, M is not in number 2, so that construction doesn't really apply either. So yeah, we only need to worry about the first one, and it completely matches that criteria. So yeah, E is the correct answer. On to the next one. On to question number 17. Uh, it says, if M is in 2 after the mice have run through the maze, K must have been in which of the following before running through the maze? Okay, so uh, we have M at number 2. If M is at number 2, we know K has to be number 5. So we have K at number 5. And now the question is, K must have been in which of the following before running through the maze. Now let's go over these ones. Let's go over these two constructions that we're provided with this one, when the bell is rung, any mouse placed in 5 always goes to 3, and any mouse placed in 3 always goes to 5. So we see here, after the race is completed, K is at number 5. So by that logic, any mouse placed in number 3 always goes to 5. So K must have been at number 3 before running the race or the maze. So the answer will be 3. Okay. Again, on to number 18. If F is in number 5 after the mice have run through the maze, M must have been in which of the following before running through the maze? So after the race is complete, uh, F is at number 5. So we have F here. Now, from the first condition, we know that M cannot be at number 3 or number 4. So M cannot be at here or here. Now, it's left with 1 and 2. So for that, we know if M is at number 2, K has to be at number 5. So M cannot be at number 2 either. So M has to be at number 1. Okay. Um, so from the condition given here, that if any mouse is placed at number 5, it will always go to number 3. And if any mouse is placed at number 3, it will always go to number 5. And we have another one of these on the line above. If it says anything that's at number 4 will go to 2, and any mouse placed at number 2 will go to 4. So basically, the change will take place like this, and it will also take place like this, which is um, 2 to 4 and 3 to 5. Now, if M is at number 1, where is the only vacant space left for it to go, which is number 1. So it will have to go at number 1. So the correct answer would be number 1. On to the next one. On to question number 19 to 22. A detective watching suspects QRS and T and their movements in and out of a downtown building has made the following observations. Every day, each of the suspects enters and later leaves the building exactly once. No suspect ever enters or leaves the building together with another suspect. No suspect ever leaves the building in the same position first, second, third, or fourth in which he or she entered the building. Um, Both in entering the building and in leaving it, R is always earlier than S. Okay, so these are the conditions that we're provided with. Now let's go to the question. Which of the following could be the order from first to last in which the suspects leave the building on a day on which they entered it in the order T, Q, R, and S? So let's go over the options. I mean, I always like to go from the last one. So let's go with number E, T, R, S, Q. I mean, we already see that T has entered the building at number one, so it cannot leave the building at number one as well because of this condition here, the third one, this one. So this is a cross out. At option D, we have S, T, Q, R. From this one, we see the last condition, this one, the fourth one. R is always earlier than S. This one is being violated because S is ahead of R. So this one is a cross out as well. At option C, we have R, Q, S, and T. We see Q is at number 2 here, and Q is at number 2 here as well. So this one is a cross out as well. And option B, we have Q, R, T, and S. Again, uh, S entered the building at number 4, so it cannot leave the building at number 4 as well. So this is a cross out. So we're only left with one option, which is A, and it is the rightful answer. But still, we will go over it. Uh, Firstly, the last condition we have R is always earlier than S. R is indeed earlier than S. And then for the other conditions, uh, T entered at 1, left at 4. Q entered at 2, left at 1. R was at 3, left at 2. And S entered last, but left second last. So yeah, it checks out all the other conditions as well. So this is our rightful answer. On to the next one. Question number 20. If on a certain day Q and T enter the building second and third, respectively, and Q also leaves the building before T does, the order in which the suspects leave the building from first to fourth must be. Okay, let's just draw out the criteria. With E, I'm denoting entering, 1, 2, 3, and 4. And with L, I'm denoting leaving, which is 1, 2, 3, and 4 as well. Okay. So let's go over what was given to us. Q and T enter the building second and third, so Q has to be at number 2, T has to be at number 3, and from the last condition, we know R has to be earlier than S. So by that logic, R has to be at number 1, and S has to be at number 4. Okay. Uh, Again, um, we know that Q will always leave earlier than T, and R will also leave earlier than S. So now let's go over to the options. Again, I like starting from the last one. So the option here suggests RSQT, but it's not possible because R has already entered the building at number 1, so it cannot leave at number 1 as well. So this one's a cross out. This one's a cross out as well. R cannot be at number 1, cross out. Again, this one has QTRS. S cannot be the last one because it has entered at last already, so it cannot leave at last. So this one's cross. Again, S cannot be at number 4. This one is cross out. So the rightful answer is A, but we'll still go over it just to make sure. QRST. Q was second, Q was first, R was first, R was second, T was third, T is last, S was fourth, S is third, and also Q left the building before T did, which is here. Q left the building before T did, and R left the building before S did. So by that logic, A is our correct answer. Question number 21. On a day on which the two suspects who enter the building first are also the two suspects who leave it first, the last two suspects who enter the building could be. So now, this is something we have to keep in mind. This is a tricky one. So I'll go over it. Here, R and S cannot be the first two. This is something we need to establish first. Because why? Because we're given the condition that on a day on which the two suspects enter the building first are also the two suspects who leave it first. So let's say R is here and S is here. To satisfy this last condition, R is always earlier than S. So now, in the leaving order, we need to make sure that they are not in their original um, order in which they had entered the building. That is, S has to go here and R has to go here. But by this logic, we are violating this last condition. R is always earlier than S. Here, S is earlier than R. So we have already established that um, S cannot be one of the first two. So let's just omit that out. Now, another thing that we need to keep in mind is R and S cannot be the last two either. Let's just say I've put R here and S here, and then for the first two, they will interchange their position because they're the first two to enter, and they'll be the last two to. They'll be the first two to enter, and they'll be the first two to leave. So, for the last two, it's going to be the same. They're the last two to enter and the last two to leave. So here the positions will be interchanged as well. R has to go at number 4, and S has to come at number 3. But by that logic, we're violating the last option again. I mean, the last condition again. So this is not possible. That is, R and S cannot be next to each other by any means. So I think that's understandable. Now, um, let's say um, we've already established that S cannot be one of the first two. So S has to be one of the last two. So now let's go over to the conditions. I mean, options. Um, Here we don't have an S, so this is a cross out. Here again we don't have an S, it's a cross out. At number D we again don't have an S, so this is a cross out as well. Now we're left with option C and option E. But again, as I've said, R and S cannot be the first two or the last two. Because if R and S are next to each other, they need to interchange their positions, and through that we will violate the last condition. So option C is a cross out as well. So we're only left with option E, which is the rightful answer. On to the next one. Okay. 22. On a day on which R enters the building second and T enters it third, which of the following must be true? Okay. Um, Again, let's start. You know what? I'll start with number A this time. Uh, R R at number 2, right? R at number 2, T at number 3, and for that last condition, S has to be here and Q has to go at number 1. And so uh, Q, okay, so Q cannot be the first one to leave because it has already entered the building at number 1, so it cannot be the first to leave the building as well. So this is a cross out. Um, Q leaves the building third. So now, in these sort of must questions, what we always need to try is to make to prove the opposite. That is, Q is leaving the building at third. So let's just make sure that there is a way where Q does not leave at third. So let's just say I'll put Q to leave, I don't know, like second. Let's say at number 2. Let's place R at number 1, S at number 3, T at number 4. So yeah, this is a possibility. So there is a world where Q is leaving the building at number 2 instead of 3. So this is a crossout. This is not a must. No. Let's go over to option number C. At option number C, R leaves the building first. Okay, so we need to try so that R is not leaving at first. So let's put R at number 2. Uh, let's put S at number sorry, R cannot be at number 2. My bad, my bad. Um, let's say R is at number 3, T is at number 4, S is at number 1, and Q is at number 2. But here, S is leaving the building earlier than R. So this violates the last condition. So this cannot be possible. This is a wrong scenario. Uh, let's assume another one. Let's say R is at number 4, S is at number 3, T is at number 1, and Q is at number 2. Again, S cannot be earlier than R, so this is a violation as well. So what is the rightful scenario here? The only rightful scenario here is that R cannot be at number 3, R cannot be at number 4. So the only where R can be is at number 1. Now, let's just say R is at number 1. I mean, I'll put Q at number 2, S at number 3, and T at number 4. Now, this is a perfectly fine and balanced scenario because you have R ahead of S, and none of the entries and the leavings are in the same order. So this checks out all the criteria. So C could be our rightful answer. But still, we will hold it for now. At number D, we have S leaves the building third. So let's just try to prove that S does not leave the building at third. Let's say S leaves its second, R leaves at first, Q at 3, and T at 4. Perfectly fine. It's a perfectly fine scenario. So R S does not have to be the third in line when leaving. So this is a crossout as well. And then option number E, T leaves the building second. I mean, we can see there is already a scenario where T is not leaving the building at number 2. So this is a crossout as well. So the only viable option here is option number C. So this is the right answer. Thank you. Uh, Section number 6, question 1 to 6. The premise is 7 airline flights 101, 102, 103, 104, 105, 106, and 107 are to be scheduled for departure one at a time on the hour from 9 a.m. until 3 p.m. The schedule must conform to the following requirements. Flight 101 must depart at 9 a.m. Flight 105 must depart later than Flight 103 and also later than Flight 102. Flights 104, 106, and 107 must depart on consecutive hours in that order. Okay, so these are the conditions we're provided with. Now let's go to the question. If Flight 107 is scheduled to depart at noon, Flight 105 must be scheduled to depart at. So let's just draw out the whole thing. My bad. 1, 2, 3, 4, 5, 6, 7. 9, 10, 11, 12, 1, 2, and 3. Okay. So we're provided here that this one 101 has to be at 9 a.m. and then sorry, and 107 has to be at 12 because it says noon. Okay, and now let's see what else are we working with here. We know 104, 106, and 107 has to be consecutively. So here we have 104. Here we have 106 and then 107. And then the last condition we know is 105 has to leave later than 103 and 102. So in these two empty boxes, here, sorry, here 103 or 102 will go. Again, one of 102 or 103 will go here. And then 105 has to leave later than those two. So the only time 105 can leave is at 3 p.m. because it has to leave later than 102 and 103. So our correct answer is E. On to the next one. On to question number 2. If flights 103 and 104 are scheduled to depart at 11 a.m. and 12 noon respectively, flight 102 must be scheduled to depart at, okay, so we're given that 103 will depart at 11 and 104 at 12, okay, and we already know 101 must be at 9 a.m. and then another premise we know is 104, 106, and 107 have to be consecutively, so 106 and 107. And now we know another from this condition here that 105 must leave later than 103 and 102. So we have two empty spaces here, one at 10 a.m. and one at 3 p.m. So we know 105 has to leave later than 102 and 103. So 105 cannot be here because that means it's leaving earlier than 103 as well as 102. So 105 cannot be here. So the only logical place where 105 can be is at 3 p.m. And here we'll have 102. So this is the correct answer. Our correct answer is 10 a.m., the time in which 102 will leave the airport. Question number 3. Which of the following lists 3 flights in a sequence from first to last in which they could be scheduled to depart consecutively? Okay, so we need 3 of such flights that can go one after the other after the other. So, I mean, let's just go over the options. It says 101, 104, and 103. I mean, this is wrong based on the last premise we have here. We know 104, 106, and 107 have to be in consecutive order, but here we have 103 after 104. So this is a cross out. We need to have 106 after 104. So number A is not a viable option. Option 2, 102, 103, 104. Once again, we cannot have 106 after 103. We need to have 104 and then we can have 106 based on the last premise. So this is a cross out as well. Then we have a similar case, cannot have 105 in between 104 and 106, cross out. And then we have 106, 107, and 103. This is a viable option because we know 107 must come after 106. So this is a possibility. We can have this condition. We can have this scenario. My bad. So we can have 106 depart first, then 107, and then 103. So this is a perfectly fine scenario, but just in case, we'll test out the last one as well. And then here we also have another problem following the last condition here. We know 104 has to depart before 106, but here it is departing after 106 as well as 107. So this is a cross out. So the correct answer is B. Question number 4. If flight 106 is scheduled to depart at 2 p.m., flight 105 must be scheduled to depart at. Okay, let's just put 106 at 2. 106 at 2. We know 101 has to depart at 9 a.m. So these are the two things that are already settled. And then we know from that last one, 104, 106, and 107 have to be in order. So, my bad, wait. Yeah, 104 and then 107. Then we're left with 3 empty spaces. And again, we know 105 must leave later than 102 and 103. So in these 2 empty spaces at 10 a.m. and 11 a.m., we will have 102 and 103. So 105 has to leave at 12 noon because it has to leave later than 103 and 102. So 12 noon is the correct answer. Question number 5. Which of the following must be true about the scheduled order of the flights? So with this one, you just have to read out the options. And I mean, one of the options here, flight 107 is scheduled to depart later than flight 106, which directly correlates to the last condition that we're provided with. We know flight 104, 106, and 107 must depart on consecutive hours in that order. So 107 must depart later than 106. So, I mean, it's a must. I mean, no questions asked. We can just take it off. I mean, you can go over the whole process of trial and error with all the other options, but I mean, it's quite time consuming. So, and frankly, not really worth it as well. So, yeah, that's the correct answer. On to the next one. Question number 6. What is the latest hour at which flight 102 can be scheduled to depart? I mean, this is another one of those which is quite obvious if you read out the conditions. For example, this condition here, the second one, flight 105 must depart later than 103 and also later than 102. So we know we need at least one flight that leaves after 102. So by that logic, the latest hour in which flight 102 can depart is 2 p.m. But then again, you might think there can be other restrictions throughout the way if we just start planting the uh, flights in their time slots. So there might be some issue, but so that's why let's just try it out at 2 p.m. and let's see if it checks out all the boxes and the criteria. So we know 105 has to be at 3 because we know it has to depart later than 102. So 102 will be here, and let's have 103 here. So we have picked out this condition here. And then we know 101 has to be at 9. So there goes 101. So this one is ticked out. Flight 104, 106, and 107 must depart on consecutive hours in that order. I mean, once again, you can just place them here, 104, 106, and 107. So the last one is ticked out as well. So if we plant 102 at the time slot 2 p.m., it checks out all the boxes, and that is why 2 p.m. is the latest time in which 102 can leave the airport. So that is the correct answer. Question number 10 to 14. The premise is a farmer is deciding which crops to plant. Either 3 or 4 fields will be planted. In each field, only one crop will be planted. Exactly the same fields that are planted the first year will be planted the second year. But no field will be planted to the same crop for 2 consecutive years. For each field, the farmer will choose from among 5 possible crops: corn, soybeans, alfalfa, rye, and barley, according to the following conditions. In any year, at least one field will be planted to a cereal grain. The possible grains include corn, rye, and barley. The year after corn is planted in a field, either soybeans or alfalfa must be planted in that field. Okay, let's go over the question. In a year in which corn is not planted, which of the following is true? Okay, in a year in which corn is not planted, which of the following is true? Okay, we know corn has not been planted. From this, we need to keep our eyes on this criteria here. So it says corn is not planted, okay? But this criteria says in any year at least one field will be planted to a cereal grain. So cereal grain, sorry. So we need at least one of these 3 to be planted. Corn is already out of the picture, so we have rye and barley. So we need to have at least one of these 2 planted in any of the fields. So let's see if we can find that criteria somewhere. Either alfalfa or soybeans, but not both must be plantable. Well, not necessarily. I mean, it's not a necessity. So, I mean, we can already tell it's not a necessity. So either barley or rye or both must be planted. Yes, this is the right answer. We have just established here that at least one cereal grain must be planted, and corn is already out of the picture. So either rye or barley or both of them can be planted or must be planted, my bad. So yeah, answer is B. On to the next one. On to question number 11. Here we see, if the farmer plants 3 fields, each of the following is a possible selection of crops for the first year except. So let's just draw it out for our ease. 1, 2, yeah. This is the year. You know what? I'll just, yeah. So this is field number 1, this is field number 2, this is field number 3. So this is for first year, and this is for second year. Okay. So we need to make sure that we don't violate any of these 2 conditions that we have in hand. One of them being we need at least one cereal grain, and the second being if corn is planted, then we need to make sure that soybean or alfalfa are planted in that field the following year. So let's go over the options. barley, barley, and barley. I mean, for barley, we don't really have any uh, set criteria like corn, so we can basically put anything other than barley the next year because we know we cannot, the exactly the same fields that are planted the first year will plant the second year. Sorry, but no field will plant it to the same crop for two consecutive years. So we cannot plant barley in the same field for two consecutive years. So we need to switch something up. So let's just say for the first year we planted barley, barley, barley. The second year we'll uh, plant corn instead of barley, rye instead of barley, and soybean instead of barley. I mean, it's completely viable. It's completely possible. So this is a cross out. Um, yeah. Okay. So let's go over the next one. Barley, rye, soybeans. I mean, again, it's same. Barley, rye, soybean. We don't really have any set criteria. So let's just say we have rye here, we have barley here, we have corn here. I mean, satisfies the criteria. We have cereal grain, rye, barley, and corn. I mean, we need it. Just one. We don't need three. But yeah, we have at least one of the three cereal grains. And the second one doesn't really come into play because in the first year we didn't plant corn. So yeah, that's completely viable. Let's just yeah. So this one is a cross out as well. Now option C, we have corn, corn, corn. Now this is where the issue comes into play. Now instead of corn, the next year we have to plant either alfalfa or soybean. So alfalfa or soybean, alfalfa or soybean. Now, uh, through this logic, we are violating the first one because uh, we don't have a cereal grain in any of the three fields for the second year. We have alfalfa here or soybean. Same goes for the other two. But alfalfa and soybean are not uh, grain crops or cereal grains, if you know what I mean. So we need either corn, rye, or barley. We cannot have corn here because from the last logic, we have to make sure that alfalfa or soybean are here. So this compilation is violating the first uh, condition. So this option C will be our correct answer because uh, the corn, corn, and corn cannot be planted in the first year. Um, Question number 12. If the farmer plants three fields to corn, corn, and soybeans respectively, which of the following selections is possible for the same three fields the following year? Okay, let's see. Uh, Corn, corn, and soybean. Okay, we need to have alfalfa or soybean here, and alfalfa or soybean here, and one of corn, barley, or rye here. So this is the compilation that we need for the second year. So let's go over the um, options. Alfalfa, alfalfa, barley, pretty much possible, definitely possible. Alfalfa, soybean, soybean, no, we cannot have. Yeah, this one does not have any cereal grains. So the last one needs either corn, barley, or rye, but we have soybean, so it's a cross out. Again, this one has soybeans, so another cross out. This one, so soybeans, okay. Corn, corn, no, we cannot plant corn 2 years in a row, so this one is a cross out. And then again, uh, we cannot have rye the year after planting corn because we need one of alfalfa or soybeans, so this is a cross out as well. So option A is the only rightful answer. On to the next one. Okay, question number 13. If the farmer plants four fields with corn in two of the fields the first year, how many crops must there be that are not planted in the first year in any of the fields but have to be planted the next year in the same field? So I'll just draw it out. So corn in two fields. So let's just say corn here and corn here. How many crops must there be that are not planted the first year in any field but have to be planted the next year in some fields. Okay, we have corn, and let's just say for the second year we can have either alfalfa or soybean. Again, alfalfa or soybean. So it says must, right? So for must, if we need to have any of the crops that are not planted here in first year to be counted in second year, then we need to make sure that so question number 13. If the farmer plants 4 fields with corn in 2 of the fields the first year, how many crops must there be that are not planted the first year in any field but have to be planted the next year in some fields? So what we're working with here is that the question is asking us how many crops that have not been planted in the first year need to be planted in the second year. So in these sort of situations, I like to prove that the same types of crops can be planted both years. You don't really need multiple different types of crops because that way it keeps things easier and it's a must question. So no matter which scenario you take, the answer will be the same. So let's just put corn in 2 of the fields first. So we know if we plant corn in the first year, we need to plant either alfalfa or soybean the following year. So I'll just do this. And now, as I said, I like proving that similar types of crops can be planted both years. So to balance out the alfalfa and soybean here, I'll plant alfalfa or soybean here, as well as alfalfa and soybean here. And then to balance the corns out and to fulfill this criteria, I'll plant corn here as well as corn here. So it checks out all the criteria, and it gives us a scenario where the same types of crops can be planted both years. Now, we don't really need to plant any additional crops that have not been planted the first year to meet any sort of criteria in the second year. So what we have been asked here is that how many crops must there be that are not planted the first year but have to be planted in the second year? But there's zero crops that have not been planted in the first year but must be planted in the second year. There's no must for us to plant, let's just say, a rye or a barley or whatever. We don't really need that. We can just make ends meet with corn, alfalfa, and soybean for both years. So the correct answer is A, 0. Question number 14. If the farmer plants 4 fields, the maximum number of fields that can be planted to grains in both years is. This one is quite obvious because we can plant as many cereal grains as possible. Now, let's just say we have planted rye, and rye. I mean, we have planted 4 fields with rye in every one of them. And in the next year, we can easily plant corn, barley, and barley. I mean, it's completely logical. It's completely logical. We can plant all 4 fields with cereal grains without any problem. But there is a scenario where you can't do it, and that scenario is if we use corn in every one of them, or corn in at least one of them. That will hinder our progress with this problem, because if you plant corn in every one of those fields, then the next year you will end up with either alfalfa or soybean, or alfalfa or soybean. Now, in the second year, we don't have a cereal grain, so this condition is getting violated. So this is not a correct scenario. Now, we need to have the maximum number of fields that can be planted in both years. So we cannot use corn, because if we use corn, we will end up with an alfalfa or a soybean, which is not a cereal grain. So we need to make sure that we are not using corn in the first year. We can use one of barley or rye. So now the scenario that is actually correct is, let's just say we have used barley and rye, barley or rye, or you can just plant all four with rye or all four with barley. No problem there. You can have corn here, you can have barley here, you can have another corn here, and then you can have another barley here. It's completely fine. You can have a rye here as well, or rye here as well. Again, it doesn't really make a difference. Rye here as well. I mean, it doesn't really make a difference. You can have a corn here. Just make sure you don't have all four of them with corn. That is a wrong scenario. So we can have, by this logic, we can have barley, rye, then we can have a rye, a rye, and a barley. It's completely fine. We can have all four. The maximum number of fields that can be planted to grains in both years is four. You can plant all four of those fields with cereal grains as long as you're not planting corn in the first year. Question number 15 to 17. The premise we're provided here with is a square floating platform is supported at its corners by four hollow vessels that are labeled 1, 2, 3, and 4. One is diagonally across 3 and 2 is diagonally across 4. Three of the vessels are each filled with different liquid NO or P, and the remaining vessel is empty, except while there is a transfer of liquid in progress. The empty vessel can be lifted to capacity by having all of the liquid from one of the other three vessels pumped into it as follows. If 2 is empty, the liquid contained in 1 can be transferred to 2. If 3 is empty, it will be transferred. The liquid contained in 2 will be transferred to 3. If 4 is empty, 3's liquid will be transferred to 4. And if 1 is empty, 1 of 3 or 4's liquid will be transferred to 1, and nothing else will take place. O is the heaviest of the three liquids, and the platform is always tilted towards the vessel containing O. The platform is tilted maximally when and only when the vessel containing O is diagonally across from the empty vessel. Okay, let's go over the question. If 1, 3, and 4 contain NOP respectively, and if there is then exactly one transfer in liquid, that transfer must have been which of the following. So let's just draw the premise here. We have 1 here, and we know we have 3 here because diagonally. Let's say we have 2 here, we have 4 here. Okay, now this is a diagonal, this is a diagonal, and then what else is possible? If 2 is empty, the liquid containing 1 can be transferred to 2, so this is a possibility. If 3 is empty, the liquid containing 2 can be, yeah, this is a possibility. If 4 is empty, 3, yeah, this one is a possibility. And if 1 is empty, the liquid containing 3 or 4 will be so this or this. So this is what we're working with at the moment. So this is the whole premise. And now we're given here is that in 1 we have N. We have N here. At 3 you have O. Okay. And at 4 you have P. And it said there's exactly one transfer of liquid. That transfer must have been which of the following. So look, 2 is the empty vessel here. And from this premise, we know if 2 is empty, the liquid contained in 1 can be transferred to 2. So N will be transferred to 2, which is option number A. So option A is the right answer. 2 is an empty vessel, and so the liquid of 1 will be transferred to 2. So N will go to 2. On to the next one. Question number 16. If P is in 4 and could be the next liquid to be transferred, which of the following must be true? So we have P here, and this has to be the next one to transfer. So we know from 4, the only place you can go is 1. So the empty vessel has to be 1. Yeah, we're provided here is if 1 is empty, the liquid contained in 3 or liquid contained in 4 can be transferred to 1. So it says P is in 4 and that is the next liquid to transfer. So it can only go to 1. So the empty vessel is 1. The correct answer is A. 19.
if 1, 2, and 4 contain O, N, and P respectively, and if exactly 3 transfers are subsequently made, which of the following could be the resulting content of the 4 vessels? At number 1, we have O. At number 2, we have N. And at number 4, we have P. So 4 transfers will take place. So the first transfer here will be 2 to 3, which is N will go from 2 to 3, which is here. So we don't have any N at number 2. So now number 2 is empty. So the second exchange will take place from 1 to 3. That is 2. O will go from 1 to 2. So that is 1. This is the second transfer. So now number 1 is empty. Now we have 2 options here. We can either take P at number 1 and have 4 empty, or take N at number 1 and have 3 empty. So let's go over to the options now. Let's see what happens. I mean, the first one we can already chalk it out. We know A is not empty, so this is a chalk out. So with B, 1 number contains N. It's a possibility. If 1 contains N, then 3 has to be empty. But 3 is not empty here, so B is a cross out as well. Now option C, O is at number 1. No, it's not a possibility. O cannot be at number 1. O has to be at number 2. So number C is also a chalk out. At number D, we have P at number 1, N at number 2. No, N cannot be at number 2. And then we don't have an empty space at number 4. So D is a cross out as well. So we're only left with one option, which is option number E, and it has P at number 1. I mean, it will have P at number 1 if we move it from here to here, the last shift. So P at number 1, we have O at number 2, we have N at number 3, and then number 4 is empty. So yeah, option E is the correct one. Next. Question number 18 to 22. The premise here is, within an array, there are 4 significant positions, position 1 through 4. When the elements forming the array R, S, E, and U are stationary, there is one of them in each of the 4 positions. Periodically, there are reorderings of the element in accordance with the following law. During each reordering, exactly one of the elements, the anchor, retains its position, and each of the other 3 elements move to a new position. Only R and U can be anchors. U can be the anchor only when it is in position 3 or position 4. Any reordering anchored by U must be followed by a reordering anchored by R. R can be the anchor in up to 2 consecutive reordering, and any given array consists of 4 elements in the order of their position from 1 to 4. So this was the given condition, and let's move on to the question. Number 18. If U, R, T, and S is an array, and if exactly one reordering occurs, which of the following can be the array resulting from that reordering? Okay, we know here R has to be the anchor because U is not in position 3 or 4, so R will be the anchor. So R will not change its position. So from that logic, we can already cross out A and S. So A and E, sorry. So we're left with B, C, and D. Now, we also know that the other element, other than the anchor, will change its position. But here, we see that P has not changed its position in option B. So option B is also a cross out. And in option D, we see that S has not changed its position. S was at 4 at the first time, and it's at 4 after reordering as well. So this is incorrect. So we're only left with option C. So option C is the correct answer. Question number 19. If R, T, S, and U is an array, and if exactly one reordering occurs with the result that S is in position number 1, which of the following must also be a result of that reordering? Okay, let's just draw it out. So for the first time, we have we have A, 1, 2, 3, and 4. Okay, And for the second time, we again have 1, 2, 3, and 4. So we know we have R, sorry, uh, R, T, S, and U. Um, and S moves to position number 1. So we know R is not an anchor, because if R was an anchor, it would have retained its position. So U is our anchor. So U will stay at position number 4, and then R will shift its position. So we have two empty spaces left, number 2 and number 3, but R has to go at number 2 because T will have to change its position as well. So T will go at number 3. So we're left with S, R, T, and U. So let's just see. Which of the following must also be a result of the following reordering? Okay, so R is in position number 3, no, not correct. R is in position number 4, incorrect. T is in position number 2, incorrect. T is in position number 3, yes, it is correct. And U is in position number 3, it's not correct either. So the only correct answer is D. T has to be at position number 3. Question number 20. If R moves from position 4 to position 1 in the course of a reordering, which of the following can also occur in the course of that reordering? Okay, so R was at position number 4, then R moved to position number 1. So R is not the anchor. So we know U has to be the anchor, and U can only be the anchor when it is in position 3 or 4. So U has to be at position 3 here, because R has already occupied position number 4. So here, and now we're left with S and T. So S and T, S and T, and then these two will occupy one of the remaining spots. So let's just move on to question number. Let's just move on to the options. If S moves from position 1, S moves from position 1 to 2. Not really. Well, it can be. Wait. S moves from position 1 to 2. I mean, it could be. So we will hold it for now. It can be. S move from 1 to 3. No, we have already occupied number 3 with U, so it's a cross out. S moves from position 1 to 4. S moves from position 1 to position 4. Can it? I mean, it can be. T moves from position number 2 to 3. No. T moves from position number 3 to 2. No. So we have S move from position 1 to 2, or S move from position 1 to 4. Now, if we have S moving from position 1 to position 4, then T will have to retain its original position, and which we know will violate a certain condition which is given here. This one, the other 3 moves to a new position. So if S is in number 1 initially and then move to number 4, then T has to remain at position number 2, which violates this given condition. So option C is a cross out as well. So the only right answer is S moves from position 1 to position 2. And we can just write it out. Let's just say S was in 1, so S will move to 2, and T will move here. On to the next one. Question number 21. If the array UFTR has resulted from a reordering, and if exactly 2 additional reorderings occur with the result that S is again in position 2, which of the following must have been the array after the first 2 additional reordering? So we have in total 4 reordering. So we will just write it out here. We'll just write it out here. 1, 2, 3, 4. 1, 2, 3, 4. So we have 4 total reordering, and for the second one, we know that we have U. Is there a USTR has resulted from it? And okay, USTR is our second one. It has resulted from the first reordering, and then we have 2 additional ones. And we know if exactly 2 reorderings take place with the result that S is again in position 2. So S has to be here. Which of the following must have been the array after the first of the two additional reorderings. Okay. Uh, for the second one, we know that R has to be the anchor because U cannot be the anchor if U is at number 1. U can only be an anchor when it's in 3 or 4. And if it was at 3 or 4 at its initial position, then it could not have changed its position to number 1 because if it was the anchor, that is. So U is not an anchor here. R is the anchor, so I'll put R here. Uh, so we can once again have at number 3 we can have R as the anchor again because we know R can be the anchor up to 2 times. So R will be here, and then we need to make sure that we have a new anchor for the fourth one because R cannot be the anchor three consecutive times. So we need to bring U at number 3 so that it can act as the anchor for the next reordering. So U can only be the anchor if it's at number 3 or number 4. So we need to have U at number 3. And then S cannot be at 2, otherwise it will retain its position and violate the law. So S has to move to 1 and T has to move to 2. So we're left with S at number 1, T at number 2, U at number 3, and R at number 4, which is here. Question number 22. If SRUT is an array and if exactly 2 reorderings occur, the first anchored by R and the second anchored by U, which of the following must be true directly after the second of the 2 reorderings? Okay, we have S, R, U, and T. First one is anchored by U, so R. First one is anchored by U, and the second one. No, sorry. The first one is anchored by R, and the second one is anchored by U. So you have to go at number 4 so that it can act as the anchor for the next reordering. S has to come at 3 and T has to go at number 1. And then here again U has to be the anchor, so it will retain its position. And then these 3 can interchange. But there is no limitation for these 3 here. It can go anywhere. T can go at number 2 or 3, S can come at number 1 or 2, and R can go at number 1 or 3. I mean, there are no restrictions here. So let's go over to the options. And the only absolute here is that U has to be at number 4, which we see at option number E, which is the correct answer. Thank you.